All right, back at it again. Um, okay, so I've made a lot of progress since the last video. I don't remember exactly where I left off. Um, but so a lot of the progress that I've made started a couple days ago. So I'm on my university's rocket club, right? And on the club, there's a team developing a hybrid rocket motor that uses solid fuel and liquid oxidizer, and they use nitrous oxide. And so I was able to meet with somebody who works on fluids for the hybrid motor because I had some questions about nitrous oxide. Reading through um, the Triple E regulations um, made me sort of rethink my decision about using watered down hydrogen peroxide as my oxidizer. Um, I mean, for reasons I mentioned before, it just makes um, everything like worse. It lowers the temperature in the chamber, and then I imagine it would lead to much lower combustion like completeness or efficiency. And anyways, so you know, but I kind of liked that it was liquid because then I could do a pressure regulated feed system, which I was thinking might be handy for throttling because if the pressure is constant in the tank, then um, I don't know, maybe it would make it simpler. I guess maybe I didn't think about that too thoroughly, um, but of course nitrous oxide would allow it would be much more energetic in the chamber because there wouldn't be as or it would be hotter in the combustion chamber. um, and so that means uh, like higher exhaust velocities, right? And so that's what we want: more efficiency, more power. Um, but I I wasn't sure how to go about any of that, because if it's not well, okay. So before I was thinking I could just like pressurize the tanks with my air compressor, um, but if I'm working with nitrous oxide, then that I can't really do that. And if I want it to be a liquid form, then it would have to be about 750 psi at room temperature, and my air compressor can't do that at all. Um, I mean, I guess I could just like mix the gases in there, have both nitrous oxide and just like compressed air, but of course, then you'd have air getting in the like a lot of nitrogen seeping away efficiency in the combustion chamber and stuff. Uh, and like, anyways, so I wasn't sure about how the logistics of that would work. And to get it up to like the pressures where it'd be a liquid, um, which um, yeah, I'm not really sure why now, but I was thinking, um, well, maybe I wasn't hard set on that. I'm having a hard time remembering what my thinking was, my sort of thought process. But um, I was I was wondering how hard it would be to get it up to that 750 psi to make it a liquid. Um, and you know what? Maybe I can make it work even without that, probably. Um, but if it wasn't a liquid, then it would at least be a lot harder to do a sort of pressure regulated feed system rather than just like a blow down feed system. So I met with that girl that's working on the fluids for that hybrid motor. And she told me that what they're using for their static fires and stuff is they have a hydraulic pump. Now, I didn't really know about hydraulic pumps before, but they're pretty cool. So there are like two inlets, right? One inlet is for just like pressurized air or like nitrogen or whatever. It's the driving gas or something like that, and that just turns the turbine, which then pumps whatever's coming in from the other inlet. Um, and so it doesn't take any electricity. So I thought that was kind of cool. Uh, and that's also basically conceptually what's going on with turbo pumps on more advanced rocket engines. Um, but where was I going? Oh yeah, so for a while there, I was sort of scanning the internet. I was on eBay and Amazon and stuff looking for cheap hydraulic pumps, and then I was like, wait a sec, what? Wait, so oh yeah, so it turns out that wait, she told me that before the nitrous oxide that they're working with goes through the pump, it's already at about 550 to 600 psi. But apparently, that's already enough for there to be liquid in the tank. Um, it, I mean, I guess there would just be more if you pressurized it more. It sort of finds its equilibrium. If the pressure is too low, it starts to evaporate, and the vapors increase the pressure, and that decreases the rate at which it evaporates, and then it finds its equilibrium. Um, and so she was telling me that they can only, since it's a hydraulic pump and not, it's not meant to pump gases. It's meant to pump incompressible fluids. They can basically only use it until they've gone through all the liquid in the tank, and once the liquid is gone, then they have to turn it off, basically. Um, but that got me thinking. I was like, okay, well, the there's already liquid in the tank, like before it's even being pumped into the engine and stuff. Um, and so, like, if I were to just go buy some nitrous oxide, what pressure would it be at? And and so I just sort of drove around town to like some welding shops and stuff like that. And it turns out you need a medical permit to buy pure nitrous oxide, but it turns out, well, that's because it's just laughing gas, right? And so hooligans and mischief makers, is that I don't know if that's a term. Anyways, hooligans will inhale it and do goofy things, and so there's regulations on the sale of nitrous oxide. But there's also automotive grade nitrous oxide, in which there's a they add a little bit of sulfur dioxide. It's only like 100 parts per million, so like a percent of a percent of nitrous oxide, which is it acts as sort of an irritant, so it's like really uncomfortable to breathe it in. But I think for my purposes, it probably wouldn't matter that much. I looked up the pressure at which it turns to a liquid, and it would turn to a liquid um, much before the nitrous oxide would. Um, but they that like welding shop that I was at, they said that they would sell it at like 220, 200, or sorry, 2200 to 2500 psi. Um, so or something like that. Um, so it's not like even though it would be condensing earlier, as it's like we're still working at like super high pressure, so that it's not really like being all that concentrated. The sulfur dioxide isn't being concentrated really more than it is, at least too much, significantly. Um, and even still, like uh, it. I'm not sure, but it might be an oxidizer. Actually, never mind. Don't quote me on that. But I mean, being in such small amounts, I really don't think it'll be much of a concern, at least for my purposes. I'm not like pushing this to the limits too much. Uh, but I've been thinking I really need to just focus and just get like the bare minimum thing that works, because it's been way too long. And I've been uh, just like lollygagging way too much. But things are coming together. I can just buy nitrous oxide at like 2500 psi and just plug that directly into my uh, engine with like some kind of regulator, I guess. So I need a regulator, anyways. Well, yeah. So for on a test stand, I can. It'll be easier to work with. And then I'll just pump it into a gas and then just close the or pump it into a tank and then just close the valve when it's at 750 psi in that tank when it um, when it's ready to fly. So I'll pump it up to a 750 psi in the flight tank. I don't know if what I'm saying is making any sense, but I'm tired. Um, but so I don't need to worry about a pump anymore. So that would save me a lot of money, but I think ultimately that can be pretty simple. But I've been thinking I'm probably just gonna ditch the fancy like gas regulated thing, like pumping in extra gas in the top of the tanks to keep them at the same pressure because it probably won't matter all that much. Because well, okay, I mean I didn't like do the math on it, but as it burns fuel, it's gonna get lighter, and so it won't need as much thrust later on. Um, but um, and yeah, so even if okay, what I was thinking before is to throttle, I would just have like two valves that I would just like adjust, one for oxidizer, one for fuel, upstream of the engine, which would probably work, but I worry that that would be less precise and there would be more of a delay there, and I want very fine control of my throttle if I'm going to accomplish my ultimate goal here. Um, and so, and at this point, I'm starting to think, maybe like Tripoli doesn't allow throttling on rockets, active throttling, but it might be fun to design this such that I can sort of do my own launches with like throttling whatever stuff I want, but then have it like cross compatible so that I can then just like take it and fly to Tripoli without any of the fancy stuff going on. And so, anyways, I think I'm going to make it official. I'm switching to nitrous oxide, even though I don't need to. I think and another thing with nitrous oxide is that once I have an engine that works, um, I was doing some math, and if we have like complete combustion within the combustion chamber and it's at the perfect sort of stoichiometric ratio as dictated by the chemical equation of um, isopropyl alcohol and nitrous oxide combustion, then the the adiabatic temperature of the exhaust before going through the throat and everything in the chamber would be like a little over 5,000 Kelvin. And so yeah, um, obviously that's gonna melt like aluminum, copper, stainless steel. There aren't very many materials that I could use to make the walls of my combustion chamber with that temperature. So I'll probably do it really fuel rich. How fuel rich? I'm just gonna kind of eyeball it. I yeah. So like after doing all of this, I'm like I've been like I've been trying to learn the math so that I can like calculate everything out, and I'm getting to the point where like I just kind of need to eyeball it and then run tests and like get measurements of what the numbers actually are because that's what it's gonna be all about. But uh, at the perfect stoichiometric ratio, I think it would be about 6.6 uh, to 1 ratio of kilograms of oxidizer to kilograms of fuel. Um, and uh, and so I'm probably gonna do more like 2 or 3 to 1 oxidizer to fuel for no reason, just because like just as a starting point. And I just have to measure the temperature. I'm thinking so. Well, okay. Triple E rules say that you can't make the combustion chamber walls out of Um, well, it says it has to be made out of non-ferrous ductile metals. Uh, and I don't know the technical definition of ferrous, but I know it comes from the Latin word that means iron. So probably not steel. But uh, um, I was thinking, I was wondering how hard it would be to do regenerative cooling. um, I was trying to think about how realistic that would be, how I might go about doing that. Um, I had an idea that I could like take a block of a metal of some sort and get a lathe or CNC lathe mill. I don't know the difference between a CNC lathe and a CNC mill. Actually, I think I do, but never mind. I seriously gotta figure out how to use a CNC lathe. But I think I could use a CNC lathe to like sort of drill out the outer shape, right, with like the combustion chamber in the throat and then the bell, and then have like grooves running around, maybe like sort of spirally or maybe up and down on the bell section, and then have another layer that I like put on top, um, and then I could like seal it around that rim with like maybe they each have like a lip, and then I like drill like and bolt them together or something. And I was thinking I mean like it really doesn't. I can't imagine why it would matter that much if um, there's a little bit of flow between adjacent tubes, adjacent channels. Maybe it would matter, maybe it wouldn't. I mean, it might, never mind. But yeah, anyways, I was thinking about how complicated that would be, and then I was reading my rocket propulsion elements book again, and it turns out that that's like a legitimate way that people use to manufacture cooling jackets or whatever, like the like regeneratively cooled engines, is they um, sort of take the base shape and like mill holes into it, drill holes into it somehow, and then they uh, I forget what the term was, electrolytic some or other. I don't know. They use that to like connect the outer shell on top. Um, but I don't think I'm gonna do that because that's way too complicated. Maybe down the road I do more of that. I was thinking so there's also what's called film cooling. I think it's called film cooling, where you sort of inject a line uh, of like fuel or something around the chamber walls, that acts as sort of a barrier between the hot um, combusting gases and the wall, right? And so it protects the wall and keeps it cool. Um, I think the Saturn V main engines use that, the F1 engines, but maybe it's just in the um, maybe it's not in the combustion chamber. Maybe it's just in the sort of engine bell part, the like nozzle area. I can't remember. But that seems like a lot simpler. Like it seems like I could just drill some extra holes in the injection plate and then just run some uh, fluid through it, run some of my isopropyl alcohol through it. I just have to figure out how wide the holes need to be. But I think I'm gonna steer away from that for now because again, like I seriously just need to like get the bare minimum thing that works, run some tests, figure out what like the actual metrics are on this thing, and then iterate. Uh, and so I'm thinking for now, I'm going to adjust my fuel to oxidizer ratio until I get to a chamber temperature of about 1500 Kelvin, um, because steel can handle that. I think actually I don't know like what temperature it starts to weaken, so maybe I need to look into that a little bit more. So maybe like 1000 to 1500 Kelvin, and that may be like way harder than I think, but I don't see why it would be. But anyways, I'll do that. I was doing some math. I don't know if it was the right math. I like I'm kind of confused because I'm getting mixed signals from like my book and different online resources about how you're supposed to calculate all this stuff. It's really confusing because it's not like people aren't saying the same thing. But I think um, oh wait, did I? I don't know if I said this yet, but I think I'm gonna go with the pintle injector. Why? Because it's really good for throttling. Um, it's much more complicated, and I could probably again make throttling work just with like a normal like plate with holes in it. Um, but um, it there are trade-offs. But I think because okay with uh with what this rocket will end up being, I think I'll want really fine control of the throttle, and I think the pintle injector is the best way to get that. Um, yeah. Um, Now, in terms of whether I want the fuel or oxidizer to be um, go on through the middle and out like that, or around the edges, maybe I should explain what a pintle injector is. You guys can look it up, but maybe I'll just I have a pen here. Yeah, I'll draw it really quick. So it's actually not that complicated. It just gets more complicated when you're actually doing it. But basically, you you have it can be either fuel centric or oxidizer centric. Uh, and um, I would still need to figure out what is more beneficial. But basically, this is a terrible drawing. But right here is the injection plate, and you have the pintle that comes down into the combustion chamber a little bit. And you have one of your propellants coming down through these tubes and going out radially right there in a circle sort of around the pintle. And then you have the other propellant coming down through these holes right here on either side of the pintle, or like around the pintle, because that's a cross section. But that's a pintle injector. Right, and so then the flows sort of collide right here and then spray out like that. And so Charlie Garcia is has been very helpful. He's got a YouTube channel and he's got a series where he designs a rocket and he also uses a pintle injector. And so I can just kind of, like cheat off of his notes, and okay, not really. But he didn't really say why, but he said that, okay, if we want to make this angle 45 degrees, that means that we want the momentum there to match the momentum there. And he never said why 45 degrees is the right angle for it to come off. But I guess 45 degrees is what I'm aiming for. So if I do 2 parts oxidizer and 1 part fuel, that means I need my oxidizer to be flowing at half the rate of my fuel so that they each have the same momentum. Because the momentum of the fluid is the mass flow rate multiplied by the velocity that it's flowing at. So now, oxidizer on the inside or fuel on the inside. And anyway, so that's the question I need to answer. I don't really know how to answer it. I was thinking I'll probably do oxidizer on the outside going down axially with fuel on the inside going out radially. Because why did I think that? I actually don't remember. Okay. Well, now that I think about it, down the road, eventually, when I start iterating on this, I'm going to start making the holy. I'm gonna improve the ratio between the fuel and oxidizer so that it burns hotter, and I think I'll eventually try to work out how to do film cooling because that doesn't seem too complicated. uh, famous last words. But the Charlie Garcia, I think he did fuel on the outside because he also has a fuel run, a fuel driven, regeneratively cooled uh, chamber wall. Um, and so if I'm doing fuel film cooling around the outside, then maybe it would be smarter to have fuel be axial and downward and oxidizer be radial and like in a circle, you know. But I need to think about that. Um, and of course, if I'm, well, yeah, that's probably good. I might change that later. I have not fully decided. But that's where I'm at. Another thing is that now that I'm working with these much higher pressures, um, I'm not sure exactly what to expect for my chamber pressure, but if my tank pressures are like 750 psi, then um, again, I don't know exactly how to predict what the pressure drop across all the plumbing and injection plate and stuff would be, but assuming, I was thinking, maybe it'll end up being somewhere around 600 psi. Uh, but I can't back that up. Again, like I just need to get a prototype built so I can test all this stuff. But that means I have to go back to these little swivel guys for my gimbal. What I found at Home Depot that I didn't see before is this piece here. It's a swivel that's got a screw attachment on one end and this little attachment thing on the other end. I don't know what any of this is called, but I love this mechanism. um, and so before, what I had is I just had a swivel screwed onto this attachment mechanism. I needed it to be this attachment mechanism because I didn't know how to do the threads. I think I figured out how to do the threads. I think you need a tap and die set is what it's called. But I don't know how that works. And it might be really simple, but it's also, I imagine it would be easier to machine that. So, maybe if I just push myself to figure out how to use a tap and die set, I could get rid of that. But point is, if I wanted it to have this cool little like clicky attachment mechanism going into the injector assembly, engine assembly, then this little piece that has both that connector and the swivel integrated is much shorter than one of these things screwed onto the swivel, right? So ignore this piece that's, so compare, behold. So the distance between the swivel, this joint here at the bottom, and the attachment point, you can see this one's much shorter. So that saves me a lot of space. I didn't like how long it was getting because, once you have like everything attaching there, then it starts getting super long. And so that means that my engine will have less leverage for the same degree turn, when gimbaling and doing that. And it also means I would have to make the base of the rocket wider, which is not that big of a deal, but anyways. So that saves me some space. It doesn't have to be as long. But then again, maybe it's better for it to be long because the four gimbals will have to be in a sort of tetrahedral formation, right? So you have the two propellant lines coming down. They each have a gimbal here at the top. and then they have to cross down like that and be perfectly in line right there and perfectly in line aligned like that. So that you have like those points and then those points, and it's like you know, a tetrahedron. That's what would be needed to gimbal in all 360 degrees. Um, and so, where was I going with that? I don't remember where I was going with that. But, oh, right. So maybe that means that it would have to be longer so that they have enough space to cross over without bumping into each other, you know. I don't know. But, long story short, I can't just use tubes anymore because those are rated for up to like 300 psi, which is not enough. Did like the flexible tubes, you know. But that's okay. I think I can make these work. It'll be harder though and more complicated. So I think that's where I'm at. Oh, and I was thinking the launch event was last Saturday, but it actually got postponed and is tomorrow. And so I'm gonna make my second attempt at getting my L1 certification. And I think the root cause of my issues with that one was that there was a screw going through the, what's it called, the rail button, the launch lug, whatever it's called, and it went into the body frame, and I think the parachute caught on that. And you know, it's possible that that is not why the nose cone came off. Like, the nose cone was epoxy to that screw. I don't think it should have come off. I'm pretty sure there was still residual mold release on the nose cone. But nevertheless, I think, I mean, even if it wasn't a problem last time, it's something I gotta watch out for this time. So my L1 rocket is narrow enough that if I pack my parachute right, it can just sit nicely on top of that screw without ever going under it to like get caught on it. So I think it'll be fine. And then I have also built my L2 rocket now. So I'll show that to you real quick. The L1 rocket is called Seraph 1, named after the fiery flying serpents that the Israelites encountered in the wilderness. And here we have Seraph 2. So yeah, I hope you like my paint job. It took way longer than it was probably worth. I gotta figure out how to do faster with these paint jobs, but I kind of like how it looks. I think it looks cool. And I have a similar thing with these launch lugs here, the launch rail buttons, whatever it's called. I have a screw going through it to make sure it's attached really well. And so for this one, it's much wider. It's like an inch wider. And so I don't think I can really pack the parachute such that it'll just sort of sit right there on top of it without going down. So I think what I'm gonna do is I'm just gonna, I don't think there's any reason why this would cause any problems, but I'm gonna tie the parachute such that it just sort of swings on the shock cord hanging down from the nose cone, and it just like sort of sits right there hanging from the shock cord, which means there will be a lot of tension in the shock cord when the motor's firing. But I did some quick math based off of the weight of the rocket and the thrust in the motor. I don't think that acceleration will be too much. It was like 20 pounds. And I tried hanging a 25-pound weight from my shock cord to see if the nose cone can handle it, and the nose cone handled it just fine. So I'm not too worried about that. Actually, I'm a little worried about that, but I think it's fine. I don't think there's much else to say about this guy. My L1 with its modifications should go about 2,100 feet, and this guy should go about 3,500 feet, I think. So yeah. Oh, and then my nose cones. So I have lost all trust in Lock Precision's nose cones. I mean, it'd probably be pretty, like, I think it'd probably be safe just to like drill 2 holes in it and like feed the shock cord through. That'd probably be fine. But I decided for these ones, I'm going to 3D print my own nose cones. Plus, I need to add some mass up to the top anyway, so I 3D printed them and did 100% infill. So these are some pretty hefty nose cones. And then you'll notice there's kind of an odd texture here on the nose cone, and that's because both for this one and for the L1 rocket, after 3D printing it, I painted it in epoxy to make it extra strong because I was worried about it breaking on impact and stuff since it's just 3D printed, you know. So yeah. Yeah, I think that's it. I got all my motors ready to go. Everything's ready to go for tomorrow. So in the next video, you'll see how that went. I'll give you an update. I'll send a video or post a video of the launch of the launches, if I remember. And I think that's everything for this video. This one has gone super long. I know these are super boring, but they're not for you, they're for me. So anyways, I think that's everything. Well, goodbye.